Alright, the last part, what I want to do is use an exponential function. So if I use an exponential function from there to there, I want to use it in the form y equals a times b to the power of x minus p plus q. Okay, so y equals a times b to the power of x minus p plus q to go from those 2 points over there. Okay, let's just move it slightly this way. Okay, so we got 5 and 2, and we got to go 10 and 7, so the option to create simultaneous equations is there. I also know that if I have 2 points, I can start with plus q, which would be my asymptote. Now if I look at this 2 points, if I just lift this a little bit, what you can see is that the graph could go through here, down here, and continue where I could make my asymptote 0, right? So I can make this my x-axis. So I can make q equal to 0. If I make q equal to 0 and then ensure that it goes through those 2 points, that would be good. So that means the graph is landing closer and closer to 0. Okay. So I'm going to make q equal to 0 for convenience. If I want to, I could also make q equals to 1. If that makes more sense, I could, and then it will, then we have an asymptote at 1, which is an option. But I'm going to go with q equal to 0, and let's see where it goes. Alright, so another thing is I don't have to find p, so let's assume I don't need p, because p is shifted left or right, and I'm going to go with the equation y equals a times b to the power of x. I'm going to try and put it into that. The first point is 5 and 2, so I'll make 5x and make y2, I get 2 equals a times b to the 5. Okay, and the second point is 10, 7, and I do the same thing. We get 7 equals a times b to the 10. Now, for both of these, I can solve it. If I put a as the subject of the formula using simultaneous equations, I'll get 2 over b to the 5 equals a, and I'll get 7 over b to the 10 equals a. And if I make these two equal, because they're both a, then 2 over b to the 5 must equal 7 over b to the 10. I bring the b to this side here, cross multiply, and I bring the 2 down here. 10 minus 5 is 5, so b to the 5 equals 7 over 2, which I then fifth root, and that becomes my b value, the fifth root of 3.5. So I found my b value now. All I got to do is put it back into the equation and get any one of those to get my a value. And so a will equal 2 over 3.5 fifth root, which is b, to the power of 5, which cancels out the fifth root, which is 2 over 3.5. 2 divided by 3.5 is the same as 4 over 7. Multiply this by 2, multiply that by 2, and I get a equals to 4 over 7. B is equal to that. I can then put that equation in there. I get y equals to a, which is 4 over 7, times by b, which is going to be fifth root of, okay, so that's fifth root, or 3.5, you could say 3.5 to the power of 1 over 5, right? Remember that. 1 over 5 is the same as the fifth root. I could get the actual value of this, which is 0.7, like that. We could get another value wherever it is, and that would be great. Okay, and then from there, after I've got that, I then click away. Let's see if it draws it. Okay, oh yeah, I've got to also include the fact that I have this is my b value, by the way, the whole thing to the power of x. And there we go, got it straight through that 2 points over there, starting from 5, which is my starting domain, less than or equal to x, which is less than or equal to 10, and that's my closing point over there. Notice we didn't need p to complete this as well, and the asymptote was chosen as 0, which is good enough. The p-value would shift it left or right, so we could use that and shift the graph right and provide a value if we needed to, but we don't, so we don't need to. Okay, so reducing my function to y equals a times b to the power of x sufficed. Asymptotes features, it's an increasing function all the way through. Alright, and it has an x-intercept. When x is equal to 0, you'll find that x-intercept will be 1, 0 and 1 as well. Okay, and that's the last part of that.